So I purchased a Creality V3 about a month ago. Firstly, I printed some toy characters for my kids, and out of the box, I was blown away by the print quality. Really, really good. Anyway, I'd been working on a vision system for a few months, and I thought this would be a good candidate for developing my project. Okay, so first step was to get to work on developing a gripper to pick up a disc that I 3D printed. The disc itself was 40 millimeters in diameter, so I designed the arms to close perfectly square at that dimension. Here I'm using Autodesk Inventor. I chose helical gears for the gears, and I did a little test run with the Creality, printed perfect. Was pretty impressed by the actual print quality itself. Even managed to countersink these holes here. That one's not so important, but the next one where the gear rotates around, that had to be countersunk, printed perfectly. Super impressed by it. So next was to print the components for the gripper arm. For the print filament, I chose PLA+. I don't think it really mattered whether it was PLA or PLA+. I've also uploaded these drawings on Creality Cloud, so feel free to download and print these. You will need a small little servo motor to fit in that slot. It's a Tower Pro SG90. I think they're pretty popular. Next it was to assemble the components of the gripper arm. Here you can just see I'm doing that, just fast forwarded it. So here I'm trying to give you a close-up view of the assembled gripper. As you can see, the gears mesh quite nicely. There's no backlash in the system. You can see as that arms move in and out, the drive gear just moves as it should. Okay, so here I'm testing the gripper arm, just closing it and opening it. Probably didn't have the best solution to control this arm itself, but yeah, as you can see, it works. Okay, now I am scaling the C-axis, so I added another motor to the gantry itself, and I'm just scaling the system here, so you can see it just went from 360 to 270, 180, 90 here now, and then back to 0. So here I am scaling one of the linear axes. I had to do this for X, Y, and Z. Obviously different to the C axis that I just showed you that holds the gripper arm. That was in degrees, these are in millimeters. Also had to disconnect the motors that go to the controller for the Creality. That will now go into my Beckhoff PLC stepper modules. Now that the motors are scaled correctly, I have a little bit more control over the actual function of the system. So here is the TwinCat environment. I'm just enabling all the motors, all 4 motors. From there I can move the motors however I want, just changing some velocities here. C-axis runs negative here, but all the limits are set, so all 4 axes have limits. It's my Z-axis. just run that back to 0 or 100 millimeters. And run it back to 0. Set everything back to home here. There's a limit there of negative 180, so I couldn't do that. Just change that back to 0. Okay, so here you can see the actual program running. So the point of the gripper arm was to pick up this disc, rotate it and put it into a slot. There's not much tolerance between the disc and the slot itself, so it's got to be quite accurate in its positioning. It's just rotating, putting it down. This test here is just checking reliability, so I'll run the test again afterwards. It's not using any vision, so predefined point the disc is at here. As you can see, the vision system on the right hand side of the camera, it didn't scan where the disc was or anything like that. It's just showing you the program itself and how it runs. You can see on the bottom right there the actual vision system. This is how it would look like if the disc is where it should be. The two red circles are the tolerance of where the disc can be, and a predefined position of where the disc should be. So it's basically its search area or outside that, which you'll see in the next video. Okay, so for the last sequence, the vision system is running. This system will come forward, scan its position, scan its coordinates. You can see in the bottom right there, it's not in its predefined position, so those new coordinates will be sent to the program. It'll pick the component up, adjust it, and put it down. And that's it for that project, guys. Thanks for watching. I've got a few cool projects coming up, so feel free to like and subscribe. Thanks.